In this video, I'd like to begin our review of Unit 10, which is on deformation and mountain building. Now, deformation involves things like folding of rock, that's known as ductile deformation, and also fracturing of rock, or brittle deformation. Both ductile and brittle deformation are ways that rock can respond to stress. So with ductile deformation or folding, the rocks may fold into an anticline or a syncline. If there's different orientation of stress applied, they may become plunging anticlines or synclines. And then we also have structural domes and structural basins that might form. Breaking of rock can form fractures or different types of faults. So all these things are examples of brittle deformation. We went over different types of faults in the unit, like our dip-slip faults, normal and reverse. Remember, a thrust fault is just a special type of a reverse fault. And then we had our strike-slip faults. So next I wanted to go over how these different types of structures form. Okay, we said that these different types of deformational structures are caused by stress. So we made a chart here with the structure in the first column. The second column is showing the type of stress that causes the structure. And then the third column indicates in what kinds of geologic settings, or in some cases you might think of them as geographic settings, are these structures found down in the crust. All right, so let's start with the anticlines and synclines, and it doesn't matter if they're plunging or non-plunging, they're all caused by compression of rocks in Earth's crust. And that compression is typically the result of plate collisions, so we expect to find these structures along convergent plate boundaries. Where could we go to see rocks folded into anticlines and synclines today? Well, we go to certain parts of major mountain systems, the parts of major mountain systems referred to as fold and thrust belts. But you can go to portions of the Appalachian Mountains, the Alps, and you can find, examples of anticlines and synclines, plunging anticlines and plunging synclines in the fold and thrust belts of those major mountain systems. They all formed from plate collisions. Then we have structural domes, and structural domes, they're typically caused by complex orientation of compression at different times, but they can also be caused by heating of sedimentary rock layers from below, like if magma is pushing up in the crust, or if there's a zone of high heat flow, like a hot spot, that can cause the sedimentary rock layers higher up in the crust to be broadly upwarped into a structural dome. So where would they be found? Well, maybe over hot spots, or in the case of complex compression creating structural domes, they're typically found kind of a little bit farther away from the major mountain systems, not right in the major mountain system, but laterally a little bit away. Our structural basins are typically caused by loading of the crust that causes the lithosphere to bend or flex downward in a central area, forming the basin. A typical place where that kind of loading will occur is where you have a major mountain system forming, the major mountain system being the load, and then we have areas adjacent to the major mountain systems where the weight of the mountain system bends the lithosphere downward, and we get a structural basin. And then sediments that are eroded from the mountain system tend to be deposited over millions of years in the structural basin. How about our faults? Normal faults, we said, are the result of the crust being under tension or a pull-apart stress for a long period of time. So we'd expect that to occur along divergent boundaries. Heating from below will also cause expansion of rock layers up above, and that can put them under tension. And another instance is where we have the heating from below create a rift valley. The sides of rift valleys or rift basins are typically bound by normal faults. Now, the downdrop side of the normal faults form the basin or the rift valley, but the upthrown side of the fault will create an uplifted area or a mountain range. So in areas where there are a lot of normal faults in the crust, the surface of the land forms a series of basins and ranges, and those types of mountain systems are called fault block mountains, or some people call them block faulted mountains. Same thing. Well, let's move on to our reverse faults, including the low angle reverse faults that we know as thrust faults. Like the folds we were talking about earlier, our anticlines and synclines, these reverse faults are caused by compression in the lithosphere. And they are typically found in the same locations as our anticlines and synclines in the fold and thrust belts of major mountain systems. Finally, we have strike-slip faults. They're the result of the crust being under shear stress for long periods of time. That typically happens along transform boundaries, where you have two plates trying to slide past each other. And the movement, the episodic movement of the two plates relative to each other, is accommodated by movement on strike-slip faults.